Okay, Precal, hopefully this is working. My Zoom is behaving a little unusually on my end. Hopefully it's okay. I'll check at the end. Let's see here. Okay, there. All right. Hopefully that's showing up. I'll check at the end of it. Hopefully I'm not wasting time. Okay, so this is the lesson for 7.4, which is finding the determinant of a matrix. Let's talk about notation first. You can see that if this represents the, you know what, I'm going to go to this other view here, if that's all right. I'm sorry, because then I can see my cursor and it's easier. And I think you can too. Hopefully you can on your end. It's real jumpy, the video on my end. I don't know. Hopefully everything's okay. Anyway, this is matrix A, right? We were in say matrix A, and it's got this squared off bracket like this. This represents the matrix A. These are the elements within the matrix. And then we can say, oh, we want to find the determinant of A. So we write DETA. But another way you can write it, it looks like the absolute value of A. It's not, because it's a matrix. So this would represent the determinant of A. That's how you write in symbology the determinant of A. Now, if you have a 2 by 2, it's laughably easy. I always tell students you take the product of the 2 downhill minus the product of the 2 uphill. Downhill minus uphill. And you can see that. So it'd be A, so that's row 1. This is the entry for element for row 1, column 1. This is the entry for row 2, column 2. This is the element for row 1, column 2, row 2, column 1. You get the idea. So we multiply these two, subtract those two. You know, you guys, I don't think I'm going to do it. I was going to get a piece of paper and do it. I think we can just talk through it, you know, right here. So if I had to find the determinant of this matrix, it would be the product of those two numbers, 4 times 5, which is 20, minus the product of these two numbers, which is 7 times -2 is -14. This is 20 minus -14. When you subtract a negative, it's like adding a positive. So this would be like 20 plus 14 or 34. That's it. The determinant of this matrix is 34. Nothing to it. The product of these minus the product of those. So that's a 2 by 2. Not much to it. They're going to ask you to find some 2 by 2 determinants. That's it. Now we're going to move on. Let me show you. We're going to do a 3 by 3. Then we're going to do a 4 by 4. We're going to do another 4 by 4. Okay. So let's go ahead and do this 3 by 3. Now it says I'm going to show you 3 ways how to do this. By the way, Mr. Miller is going to, I think, experiment with yet another way. And I'm kind of curious how it goes. Because if it's successful, I might want to try it that way. I'm not convinced quite yet that it's the better way to go. Anyway, let me write this matrix. This matrix down. It's -3, 0, 0, 7, 11, 0, 1, 1, 2. All right. I'm going to show you all the different ways, 3 ways that I want you to know how to do this 3 by 3. The first way being the most garbage, horrible way to do it. I'm very reluctant to show you this because students often fall in love with this method, and I don't want you to at all. And I'll tell you why I don't want you to. This only works for a 3 by 3. It only works for a 3 by 3. Okay? So it's not versatile. All right, I'm going to leave it at that. But here's the most garbage. Okay, what you can do is you go row 1, row 2, row 3, and then you repeat row 1 and row 2 again. In other words, okay, here's row 1. I'm going to write that 3, 7, 1. This one is going to be 0, 11, 1. And here we go. I'm going to use different colors, I think, of pens. Oh, I picked 3 and there were 3 different colors. I just grabbed 3. That was perfect. Now, what you're going to do is you're going to take the product. You're going to go diagonal, just like remember how you went downhill minus uphill again? You're still going to kind of do downhill minus uphill. We're going to take the product of those 3 plus different color. So the product, please keep in mind, this is the most garbage way to do this. Hopefully the green, yeah, it does. Green and blue kind of comes out a little different. The product of those 3, and now black. And maybe I should get rid of this, a little more contrasting. And there we go, the product of those 3. let's do that right below right now. This would be -3 times 11 is -33, and -33 times 2 is -66, plus 0 times 0 times 1 is 0, and 0 times 7 times 1 is 0. Minus, now we have to go uphill 3 at a time. So I'm going to take the product of those 3. I hate this method. I should just really not do it. Plus the product of those 3, plus, excuse me, the product of those 3. Okay. So what that's going to be is we're going to get, so minus in a grouping these 3 here. 1 times 11 times 0 is 0. 1 times 0 times 3 is 0. And 2 times 7 times 0 is 0. Pretty simple. Pretty simple here. This is -66 plus 0 plus 0 is -66 minus 0 plus 0 plus 0 is 0. So the answer is, for the determinant of that original 2 by 2, excuse me, 3 by 3 is -66. Okay, you ready? Now, this method only kind of works, frankly, only works for 3 by 3s as well. And I don't know how to describe it. Let me write the original system again. -3, 7, 1, 0, 11, 1, and 0, 0, 2. But I will tell you, if I have a 3 by 3, if I do, this is the way I do it. And what I'm going to tell you, I don't know how to describe it other than you just do it. You go, what do you mean? You just do it. And here's what I mean by that. All you're going to do is you're going to multiply downhill again, downhill 3 numbers at a time, 3 numbers at a time. So let's do that. And then minus the product of those 3 added together. Anyway, here we go. Downhill, -3 times 11 times 2. So I'm going to take those 3. -3 times 11 times 2 is -66. We're still going downhill. We got to do 3 at a time. So that's going to be 0 times 0 times 1, right? 1, 2, and 3. So see if I can do that with colors. It would be the blue, those 3 numbers. And then we're going to multiply those 3 numbers. And finally, we're going to multiply. And I'm going to tell you that the 3 by 3, this is how I do it. Those 3 numbers. So keep going on. It's going to be 0 times 0 times 1. Yes, these are the same numbers as we were getting before. This is 7 times 1 times 0, which is 0. Minus, now we have to go uphill 3 at a time. It's a pretty bad looking picture I'm drawing. I usually do better than this. That's going to be 1 times 11 times 0, which is 0. This is going to be 1, and the order doesn't matter, just 3 at a time. Going uphill this time, 1 times 0 times -3, those 3 numbers is going to be 0. And now we got to do in black going uphill, 7 times 0 times 2, which is again, obviously 0. And you can see it's what we got before. It's -66 plus 0 plus 0, which is -66. Minus 0, which is -66. All right, now this is the way really to do it, the third way that I'm going to teach you, because this is versatile. You could do this for any number of rows. It's pretty complicated as the rows increase. Let me write out what I got. I got -3, 7, 1. Again, this is what we're trying to find the determinant of. We are 0. Obviously, we should get the same answer each time. And 1, we got 0, 0, 2. This is called by doing it by minors. All right, what you want to do, and it doesn't matter which row you choose. I think you can choose a column too. I think I'm almost positive. You want to choose a row that has the most number of zeros because it makes your life easier. Okay. Having said that, you can choose any row or column you want. It doesn't matter. So I'm going to hit pause for a second. I want to find something. Okay, I'm gonna make sure I'm recording. Yep. Okay, I just want to make sure that a column works as well. And I was like 99% sure, but you always want to make sure that you're not saying something untrue. So if I was looking at this, I'd probably want to choose row 1 or column 3. It doesn't really matter. Let's be clear. You could choose maybe the worst one, which would be column 1, right? It would be absolutely okay. No worries. You're going to get the same answer. I was going to say maybe we'll try it. Let's try it. Even though I'm kind of running out of time before the bell's going to ring, that's okay. I'll just hit maybe I'll do a part 1, part 2 again. All right, so let's talk about this. Let's go ahead and do it the proper way first, which is to choose a row or a column. Let's choose this column. Let's choose column 3 because that looks like it has no negative signs, smaller numbers, zeros. Super nice. Okay. So what you're going to do is you're going to take that row. Well, okay, before I talk about it, my bad. Before I talk about it, I want to show you this. Let me hit pause. So I'm not just thumbing through a book looking for it, because this picture is going to be critically important in order for this method. That's versatile, that can be used for which we're going to have to use for 4x4s and so forth. Okay, and again, let me make sure, because I've done that before where I thought I resumed, I haven't, and you have to do the thing all over. Okay, here's the sign pattern for a 3x3, a 4x4, and then it don't matter how big, right? N by N, so whatever. You go, do I have to memorize this? I would raise an eyebrow and go, yeah, I guess there's not really much to memorize, because you always start in the upper left-hand corner with a positive, and then it just alternates whether you're going down or across. So this would be like plus, minus, plus, minus, plus. Get the idea? Or this is going to be plus, minus, plus, minus, plus, minus, plus. They just alternate signs. That's going to be critically important. That's going to be critically important. Okay. So here we go. Once you understand this sign chart, we're going to go ahead and put every single one of those numbers down that we have here. It's going to be 0, 0, a little bit, I guess, kind of have them over there too. 0, 0, 2. Now let's look at the signs for each of those we have to put in front. Positive, negative, positive. So this is going to be a positive. This is going to be positive, negative, positive. That's going to be a negative. And yes, I know, positive 0, negative 0, that's just 0. Again, positive, negative, positive, negative, positive. That's going to be a positive 2. All right. Now what you're going to do is for this one, that 0 represents that 0 right there. What you do is you cover up the row and the column for that one. And you are left with a 2x2 matrix. 7, 11. By the way, we should get the same answer, right? Which was negative. 7, 11, 1, 1. Let's write that. 7, 11, 1, 1. And this is going to be, okay, that 0 represents that 0. And we're going to cover up the row and the column. Boy, I wish it would work a little better. The row and the column that has that 0. That row and that column that contains that 0. So what I'm left with is negative 3, 0. Okay, look at it, Freud. I'm doing this and this. So it's going to be 1, 1. Okay, and then next, that 2 right there, that represents that 2. So I'm going to cover up that row and that column. And I'm left with this right here. This is going to be negative 3, 0, 7, 11. All right. This is going to be 0 times, here, I'll do it. Even though it's 0 times anything is 0, we know that. This is 0 times, but let's get used to finding the determinant of 2 by 2. It's going to be 7 minus 11. But we don't care, because that's negative 4. 0 times negative 4 is going to be 0. This is going to be 0 times negative 3 minus 0. That's how you find the determinant of 2 by 2. We know those are zeros. And this is going to be 2 times negative 33 minus 0. And again, we have 2 times negative 33 is negative 66, but of course we knew it had to be same thing. Now, I told you, just for grins, let's just go ahead and pick a different row. That's harder. It's going to be harder to do. You go, why would you do that? Just to show you that it doesn't matter. It doesn't matter what row you've chosen. It's going to be -3, 0, 0, 7, 11, 0, 1, 1, 2. And I said, hey, this looks like this would be the hardest one to do. So let's go ahead and do it. It's three numbers for that column are -3, 7, and 1. -3, 7, 1. Now what we're going to do is we're going to use that sign table, which is negative. That's going to be a positive. So that stays the same. That's going to be a negative. Boom. That's going to be a positive. Positive, negative, positive. So keep the sign, change the sign, keep the sign. All right. Now the 2 by 2s we get for each of these. I'll put a plus sign just so I don't get confused. There we go. So if I cover up that row, and I apologize, I wrote like a 2-year-old. Again, I apologize. If we cover up the row in the column that has a -3, I have 11, 0, 1, 2. And it's going to be equal to, I'm not sure even what that is. So we get rid of that. It's going to be -7. So let's cover up that row and that column. And I got 0, 1, 0, 2. And then this one, I'm going to cover it up here, cover it up here. That's going to be 0, 11, 0, 0. Here we go. It's going to be -3 times 11 times 2 is 22, minus 0. It's going to be 22. It's going to be -7 times 0 minus 0 plus just 1. So I'm just going to make it like that. 0 minus 0. And so that's going to be -3 times 22, which is again -6. Come on now. It's the same thing every time, right? So it doesn't really matter. But again, what's going to make your life easiest is if when you have this matrix here and you're looking, especially when you get to a 4x4, boy, you're looking for rows and columns with the most number of zeros. It's going to make your life easier, and it doesn't matter. Again, that looks like the easiest one because there's no negative signs. And the numbers are 1 lower, 2 to 3. Yes, I know negative, but saying that's it. Okay. Now let's look at a 4x4. I'm not sure I have time, but I'm going to try. Let me look at real quick. I might have some. It is a Thursday today. 52. I got a little over 15 minutes. I might be able to get through one more slide. All right. All right, let's look at a 4x4 here. Okay, now I think you can see it. I think you can see it. If we had to find the determinant of this matrix, if there's a whole row that's all zeros, you could pull those out and, you know, and then end up with 3x3s, right? You can say, oh, I'm going to choose that row. That has the most number of zeros. That's going to be 0 times a 3x3 matrix. It's going to be 0 times a 3x3 matrix. It's going to be 0 times a 3x3 matrix. It's going to be 0 times a 3x3 matrix. Well, 0 times anything is 0. So it's going to be 0 plus 0 plus 0 plus 0, right? And that's 0. Anytime you see a whole row, one whole row of all zeros, or one whole column for that matter, of all zeros, you know the determinant's going to be 0. Okay, so that one went fast. That one went fast. All right. Let me pause for a moment. All right, let me make sure. Sorry about that. All right, so here's a 4x4 where the determinant is not 0. And we're going to look at that. Now remember, you want to choose either a row or a column that has the most number of zeros. And that's going to make your life easier. So I'm looking here, and I want you to try to tell me which row looks the best to you. Right? You can hit pause if you want, but I'm going to say the answer. I'm going to go with row 2. It's got 2 zeros, right? I don't see 2 rows with a 0 in it. So I'm going to choose that one that's -2, 0, 6, 0. Let me write those out. And let me actually write the matrix out that we're trying to find the determinant of. 3, 6, -5, 4. Let me hit pause. So you're not just listening to that. Okay, and let me verify it. Yep. Okay, So here it is. We're trying to find the determinant of this matrix. All right. So what we said is that appears to be, that one right there appears to be the best row to choose. And I'm going to go it is. Okay. So let's write those four things out. We have, actually, you know what? Let's don't. Don't we know that if we have that entry as a 0, it's going to be 0 times the determinant of a 3 by 3, which would just be 0. So I'm just going to use 2. I'm not going to write out 0, but there's no point to that. Now I'm going to write, temporarily write just a 6. We'll figure out if it's a plus 6, and this might become a positive. Let's see. So remember the signs. This is important. Plus, minus, plus, minus. And if you go down, also plus, minus, plus, minus. So it's going to be plus, minus. That means I have to take the opposite. It's going to be a plus 2. That's going to be a minus, plus, minus. It's going to be a negative 6. All right. Now, if we take that entry right there, that 2, yes, it's negative, corresponds to that positive 2, we're going to cover up the whole row and the whole column that contains that. And the remaining 3 by 3 I have is 6, negative 5, 4, 1, 2, 2, and 3, negative 1, negative 1. And then I'm going to take this 6 corresponds to this negative 6. I'm going to cover up that whole column and that whole row that has that 6 in it. I have 3, 6, 4. I have 1, 1, 2. I have 0, 3, negative 1. All right, let's talk about it. We have 3 by 3s. The second slide, I talked about 3 different ways to do it. The first 2 ways are not versatile because they only work for 3 by 3s. The third way was by minors again. So you'd have to take 2 and now you're looking for a row that has the most number of zeros if you can. There are no zeros in this one, so maybe I'd want to choose that row right there, right? And you'd want to do 2 times and then, you know, pull out the 1, do a 2 by 2. You could. Or as I said, when I get a 3 by 3, my favorite way is just to do it. So I think I'm going to do that. Just do it. It's going to be 2 times, and I'm going to put a bracket like this. And I got to go 3 numbers downhill 3 times, 3 numbers uphill 3 times. So this is going to be 6 times 2 times negative 1 is negative 12. This is going to be negative 5 times 2 times 3 is negative 30. And then I'm going to go downhill one more time. 1 times negative 1 times 4 is negative 4. Minus, now I got to go uphill. 3 times 2 times 4 is 24. Negative 1 times 2 times 6 is negative 12. And 1 times negative 5 times negative 1 is positive 1. Minus 6 times. All right, now we're going to go 3 at a time downhill, which would be 3 times 1 times negative 1. It would be 1 times 3 times 4. It'd be 6 times 2 times 0. Yikes. Put that bracket there. Minus, now we're going to go uphill. 0 times 1 times 4 is 0. 3 times 2 times 3 is 18. And 1 times 6 times negative 1 is negative 6. This is going to be 2 times. And I got negative 12 minus 30 minus 4 is negative 46. Minus, I got 24 plus 5 is 29. And 29 minus 12 is 17. Minus 6 times. It's going to be negative 3 plus 12 plus 0 is 9. Minus, it's going to be 0 plus 18 minus 6, which is 12. This is going to be 2 times negative 46 minus 17 is negative 63. minus 6 times 9 minus 12 is -3. 2 times -63 is -126. -6 times -3 is 18, which is -108. And yes, it is. But let me just check and make sure that's the right answer. Make sure I didn't make any mistakes. Okay, it was right. I didn't make any arithmetic mistakes. Stupid, silly, anything. And that's it. That's it. So now I'm going to do like a 5x5 in class, but I won't expect you to be able to do it unless it's like an extra credit maybe or something. But I'm just saying, okay? So I think I'm going to leave it at this for the lesson. In class, I'll go a little further, but that's good enough. That's good enough for, you know, if you missed a day or whatever. All righty, catch you in class.